Alright, so in this video we're going to take the square root of our independent variable and plot our dependent variable against the square root of the independent variable. So we can get rid of this little data table that we used to plot our previous graph, and now we're going to have here square root of mass, and the units for that are going to be square root kilograms. I don't know if I have a symbol here that I can insert here. Function, no, I don't want to do that. No, I'm just gonna write square root kilograms. When we square root a variable, its unit will also be square rooted. That goes for any transformation that we do. And then I'm going to have uncertainty in square root mass. Square root mass. That's also in square root kilograms. Okay. I'm going to just word wrap this one as well. And then in the other two, I'm just going to have these ones. So I'm just going to take those ones, copy them, click here, right click, and paste special values only. Alright, so now I have all of those, although these ones were reduced to 2 decimal places. So I'm just going to increase those again, so that the precision of the period matches the precision of its uncertainty. Note that all the uncertainties are one significant figure, and once they've been reduced to one significant figure, we just match the number of decimal places in our value. So the square root of the mass is just going to be equal to, and we write SQRT, open bracket, and then we choose our first mass, like so, and we hit enter. So that's the square root of 0.100. And I'm going to autocomplete that for all 6. The uncertainty in the square root of mass, this is probably the trickiest cell to work out in our results table. But remember, what we need to do is we need to take the relative uncertainty in our original measurement. We need to multiply that by the power. When we're square rooting, the power is 1/2. And then we need to convert it back to an absolute uncertainty by multiplying that new value by our square root of mass. So I'm going to do all those steps slowly and just explain what I'm doing. So I'm going to go equals to this uncertainty divided by this value. That's the relative uncertainty in my original one. I'm going to multiply that by 0.5 because I'm square rooting. If I were squaring, I'd multiply by 2. If I were taking the inverse, I'd multiply by 1. If I were cubing, I'd multiply by 3. So now I've found the relative uncertainty of my new value, but I don't want the relative, I want the absolute, so I'm going to convert it back to an absolute by multiplying that by this. Okay, so once again, I took 0.003 divided by 0.100, multiply that by 1/2, and then multiply that by back by this value to get it to an absolute uncertainty. Okay, and then I'll autocomplete the other ones. Okay. And now I'm going to, these are all to one significant figure already. So I'm going to just do this and reduce them all to 3. I'm just going to double check. They are, yeah, they are. Okay, so now I have my transformed data here, and this is the data that we're going to very carefully analyze, because this is going to lead us to our equation. I might just add some borders here and then take this whole thing and copy it into here. So the transformed data, is that a heading 2, was it? No, heading 3. Okay, so you can choose your heading level here. Okay, so the transformed data looks like this. I'll just paste this here, paste unlinked. So there's our transformed data, and now, in fact, it looks a bit ugly, so I'm going to just center those. Okay, and now we want our processed graph. Alright, so let's do the same thing that we did before. In this case, we'll take all of these things, copy it, go back into an NZ grapher, Now I don't know if I want to restart this whole thing, but if I go import from clipboard, yeah, so there, now we have all the data. And the graph type we're going to choose is again a scatter graph. And variable 1 is going to be the square root of mass. Variable 2 is going to be the period. And so that looks like it's straighter than it was, and it looks like it's heading down maybe close to 0. So what I want to do next is I want to add things that, like error bars to this. So I'm going to go down and add horizontal error bars. Now error bars represent the uncertainty, so the horizontal error bars are going to be the uncertainty in my square root of mass. So uncertainty in square root of mass. So now you can see I've got my horizontal error bars. I also want vertical error bars. That's my uncertainty in the period, this one. So those are all of my error bars. I wonder if I can remove my little I'll reduce the point size because those circles are kind of getting in the way of my seeing the error bars. There we go. And then I want to add a straight line. So that's a regression line. So you can see that the regression line goes through almost all of my points. It doesn't quite go through 0, so that'll give me something to talk about. I also want to add a second line here. So I'm going to add a custom line, like so. And I'm going to show the equation of that custom line. And the purpose of this line is to show what the... in fact, I'm not going to do anything while I explain it. The purpose of this line is to show another line that can go through all of these points, but which has a different gradient. So what I'm going to do is I'm going to make it go through the bottom of that top point and the very top of my bottom point. Okay. So, in fact, if I go a little bit further out, I'll be able to see better what's going on here. I want to make sure it goes through the error bars of my top point. That looks pretty good. And I want to make sure it goes through my error bars for my bottom point. That looks like it's just kind of catching the edge of that one. So this is a line. The purpose of this line is to show how different the gradient can be while still going through most of the points. Now, you can see that I've ignored this one here and I've ignored that one there, so maybe this is not such a great line. I want to go through most of the points. So maybe if I do it the other way around, if I make it as steep as possible instead, while still going through, something like that. And then this one is kind of just maybe scraping the top of that one. And it's now going through this point, it's going through this one's error bars, it's going through this one's error bars, and this one, and this one, and this one. So this is a better line to have as my error line. So how I figured out how to do that is I went through the very bottom of my lowest point and the very top of my highest point. I tried the other way first, so I'm going through the lowest and the highest, but that meant that I missed 2 of my points, so this is probably a better error line. Okay, so now I've done everything I need on this. I can just double check that the labels are correct. I can add a graph title, so let's add that. Where do I do that? Here. So I can say this is this is period versus square root mass for mass spring system. Okay, did that. Let's update the graph. There we go. And then I'm going to just right click on that, copy the image, go into here and paste it in. Alright, so now I've obtained my linearized graph. The next thing to do is to get my equation out of this graph. So I'll do that in the next video because that's a slightly involved process.